So we're going to be converting these whole radicals to mixed radicals and mixed radicals to whole radicals. So the idea is that we want to take out, first this is a square root, so we want to look for perfect square factors in this expression here. So we can look for perfect square factors. In this case, we know there is a factor of 4, and if we factor that, we end up with 4 times 52. Okay, 52 also has a factor of 4, so we need to then factor that into 4 times 13. Okay, now if you recognize that this is divisible by 16, you could have just written it as 16. Here, once we identify our perfect square factors, those need to come outside the radical. So we end up with 2 times 2. Okay, and we're left with the root 13 inside the radical. So then this simplifies to 4 root 13. To put a mixed radical into a whole radical or entire radical, we can look at the index here. We have to power the expression up to be able to put it inside. Essentially what we are doing is we are putting that expression under a fifth root. And if we're going to put it under a fifth root, so keep the same value, we're going to power it by power of 5. Okay? So basically the big idea in math is that if we're going to apply a fifth root to it and apply a power 5 to it, that they undo each other and we have the same expression that we started with. So once we have it in the same index, we can write it all under one index. 4 to the power 5, that works out to be, I need a calculator for this one, 4 to the power 5 is 1024. So 1024 A5 times 3A, and then we can simplify that to 3072 A to the power 6. Okay, so we have that as a whole or entire radical. Here, when we can add and subtract this, we can reduce these to lowest terms first if we like. One thing that I would always suggest is if you see a common factor that you can simplify, I would maybe simplify that first and then do the other parts. So here there's a common factor of root 5, root 5, root 5. So I'm going to divide out that root 5. So we're going to end up with square root 25 minus 3 times 4 all over square root 2. Now when we do that, notice that we're just left with those perfect squares. So that makes it nice and easy. 5 minus 3 times 2 all over square root 2. So we end up with negative 1 over root 2. Now in grade 11, what we should rationalize the denominator. Now when we get to grade 12, we're probably not going to worry too much. In calculus, we don't worry too much about rationalizing the denominator. But we do want to rationalize the denominator because it is easier to determine the size of this fraction. So to rationalize this denominator, we're going to multiply the bottom by root 2 and the top by root 2. We don't want to change the value of the fraction. And by doing so, we're going to essentially multiply by 1, okay, which doesn't change the value of the fraction, and it moves the root to the numerator, and root 2 times root 2 becomes our rational denominator. Here to add and subtract, we need a common denominator. We cannot simplify this fraction, so we need to ask ourselves what factor is missing from each of these denominators to make it look like the other one. So they are sharing a common factor of cube root of 3x. So we're missing a factor of 2 here. And since we add a factor of 2 on the bottom, we have to keep the fraction the same, so we have to do the same to the top. Here then we've generated a common denominator. Okay. Once we've got the common denominator, we can add and subtract the numerator. So we're going to end up with 3 minus 2, or 1 in the numerator, and then we get 2 cube root of 3x. Okay, and again, we want to rationalize the denominator here. So we need to, since the index is a cube root, we need perfect cubes. So to get a perfect cube in the cube root, we need to first start off with a cube root. I need to multiply by 9 to get my cube root of 27. And I need to multiply by x squared to get my perfect cube of x cubed. Okay, do the same to the top to keep this fraction balanced. Okay, that's a very important concept, making sure we're keeping these fractions balanced. And we end up with the cube root of 9x squared over the rational number of 2 times, this is going to end up being the cube root of 27x cubed. Okay, and then that we can simplify that to, this becomes 2 times 3x when we cube root 27x cubed. Okay, and then our final answer is going to be, we should combine those terms. So we end up with 6x in the denominator. Okay, so here is the solution when we have with a irrational denominator. This is a solution when we've rationalized the denominator. Here we're going to rationalize this denominator. Now, when we have square roots and we have binomial square roots, we can rationalize this, but we have to make sure that we know the strategy is to use a conjugate. Okay, so we're going to use a conjugate, and the conjugate is when you have 3 minus 2 root 5x. If that's one of your binomials, the conjugate binomial is going to be 3 plus 2 root 5x. Okay, so if we multiply by that, when we distribute this out, the middle term always cancels out, and we end up with the square minus square. Okay, this is from the quadratics unit when we had a plus b times a minus b. It gave us a squared minus b squared. Okay, so if we multiply the bottom by that, we have to multiply the top by the exact same thing. Okay, so when we multiply this all out, we just have to be careful with our binomial multiplication. Okay, so we're going to end up with, I'll do the numerator first. We're going to end up with 3 root 2x plus 2 root 10x squared. Actually, I'm going to do this on a separate line so it makes it a little bit neater looking. So again, 3 root 2x plus 2 root 10x squared. Inside is 1 times 3. Last is going to be 1 times 2 root 5x. Okay, all over, and we're going to end up with 3 squared minus 4 times square root 5x squared, which is just 5x. So I've rationalized my denominator, and I really should see if there's any like terms. There aren't any like terms here, but this x squared should come out. So the numerator is going to look like this: 3 root 2x plus, so this is root, plus 2x root 10 plus 3 plus 2 root 5x. Okay, again, there's still no like term, so I'm not going to combine anything there. And this just becomes 9 minus 20x. Okay, again, this is a binomial. We cannot group those together because we have 9 ones here and 20x's here. They don't go together. So there's my final answer.